In order to test the hypothesis of grooves formed by rolling, sliding, and bouncing boulders along the surface of Phobos, this video conducts a brief equatorial tour of the grooves of Phobos. The model is based on NASA data that Thomas converted into a shape model. The underlying Phobos texture comes from shrimp, and the overlaid map of the grooves was produced by Mary. The animation rotates. We get a good look at Stickney Crater, and the first thing to note, the grooves are cross-cutting inside of Stickney. And looking to the east of Stickney, now we're on the Mars side of Phobos, we can see a large number of grooves radiating from that direction. And then looking to the north, there's also a large family of grooves that wrap over the top of Phobos. We're passing the zone where there are no grooves. And now we're currently on the far side of Phobos, coming around to the leading hemisphere, where we see a lot of cross-cutting in many directions, orthogonally and also diagonally. The grooves come in a variety of forms. Most are in the neighborhood of 80 to 200 meters in width. We see them very often covering up to 30 kilometers in length around the surface of Phobos. Narrower grooves, the 80 to 200 width grooves, often come in parallel groupings, so we call them families. That's a term derived by Murray. And these families often cross-cut each other. And then there are dozens, a smaller number of larger grooves, 200 to 400 meters wide, that seem to be more solitary, and these also cross-cut singular grooves and families of grooves. The larger grooves seem to be, not in every case, but seem to be a little bit more irregular in terms of their direction and their morphology. They're more pitted, heavily pitted, and so forth. So that concludes this video 1, and we will progress on to the actual testing of the model.